Hello all. While we select a component, we do consider the requirements for our product and then select a component based on its specifications, right? Like for example, if we talk of an op amp, that's what we are showing here. This is a current sense amplifier. So when we want to select that component, the important parameters that we check is what is the gain, and then what is the supply voltage that it will work for, and other important parameters like CMRR, offset voltage, and input bias current. So these are the major parameters, and then obviously the power PSRR. So all these parameters we do consider and then select the op amp. When we say consider, generally what most of the design engineers do is, example, if you take gain here, okay, gain is given as 20 volt per volt. So, um, they do see this and say yes, I'm this op amp suits my requirement as per my gain requirement, and they'll go ahead with the usage of that op amp. Obviously they'll also do a trade-off between different parameters, but what is the other important parameters most of the hardware engineers do tend to miss while selecting the component? That's the actual point of discussion that we are going to do here. So um, what are those parameters are? The first thing, when you see a data sheet, right, generally these all parameters shall be characterized by that manufacturer, and then they will be included in the data sheet. What do we mean by characterize is they'll measure in practice, they will see the variation, and then all these measurements are done on test bench level, and then these are included in the data sheet. When we say test bench level, basically they do at the room temperature, and some of the data sheets also mention the figures, the diagrams of how they have done it, what is the input voltage they have provided, what is the kind of voltage that they have tested with. So along with those figures, if you see the electrical specifications, you see here at 25 degrees centigrade, supply voltage of 5 volts, input of 12 volts, and we sense again this is clear, right? So considering these parameters, op amp is selected, op amp is characterized, that means the specifications below are done only with these parameters. No other conditions are considered. Like for example, if you see this INA 215 data sheet, it supports up to 125 degrees centigrade actually. Now this parameters, actual electrical characteristics are mentioned at 25 degrees centigrade. So most of the design engineers do tend to miss out on this particular condition, and just they check the specifications directly. So while the experienced engineers do know these things, the college graduates who are just get into the electronics field, or a minimal experienced guys do tend to struggle with these parameters because because either it could be lack of guidance, or it could be that they are using it for the first time, mm, where they tend to get confused. So that is one thing. Characterizing and mentioning the specifications at particular values is one thing which is very very clear. And the second thing is, if you see here, the swing to ground or swing to voltage supply rail is mentioned at a particular load impedance, and the temperature range is covered, but this is done at a load impedance, particular load impedance. Then the load capacitance, basically it's not a load impedance, it's a load resistance, ultimately the load that you are going to connect onto this, right? And then the capacitance. So the bandwidth is also done if the capacitance is 10 pf. So if your load is different, then again the entire thing is going to vary. So this is again, you don't find a clear calculation in the data sheets. This again, most of the engineers do take it by experience. Like example, if you want to use this entire bandwidth of 350 kilohertz for this particular device, you have to have a load of 10 pf. Like example, if you have a load of 100 pf, this may not be applicable. The actual bandwidth coverage could be much lesser. Now, scenarios, this is what design engineers, hardware design engineers, the wording hardware design engineers should be very, very careful while selecting the components. So while this is an example, every data sheet that they consider, they need to check the conditions at which the datasheet parameters are mentioned. So there are other kind of scenarios where we see with engineers, they do a full thorough read of a data sheet because that's what they are guided, but they tend to miss out on simple configuration. So there are two things here. One is reading the data sheet and implementing the design as per the required specification. So that's the actual challenging thing, because your application only, a particular design engineer only knows on the manufacturer of this particular device doesn't know where you are going to use this. He is only going to give specifications as per his device functionality, but the actual working conditions of a particular design depends on what the design engineers have been working on, and that they need to be clear and apply the datasheet parameters, apply their intuition, and come up to a conclusion, do all the required trade-off analysis that are required, and apply all the calculations that are required, and then use this particular datasheet. So very, very important criteria. These things should not be missed out. So the actual conclusion here is, don't just go by the values that are mentioned on the right side and the parameters that are mentioned. Do give thought into the conditions. So this is a very, very important thing, and do also give thought into which these electrical characteristics are specified. So sometimes, luckily, these may not play a bigger picture in your design, but what happens is, these do play a significant role if you are designing critical electronics designs, and your accuracy, every parameters are very, very important. So ultimately, when you do things practically, you realize that the theory that is mentioned in the data sheet is not matching with the practical scenarios, because there is clearly a variation here itself, which is mentioned in the data sheet and the practical design that you are doing. So the compensations, the required things that you need to do are all design parameters that you need to consider on your board to achieve the correct functionality of this chip. So hope we just try to give some glimpse into what things do hardware design engineer miss out while reading the data sheet. Please post your questions. Please let us know if you have any comments. Thank you.